Alright, Geometry 2-2, Angle Relations. Today we're going to learn about complementary and supplementary angles. Alright, complementary and supplementary angles. Complementary angles are two angles that when put together add up to 90 degrees. Supplementary angles are two angles that when added together equal 180 degrees. Now there's a couple of ways to remember this. One, C comes before S in the alphabet, and 9 comes before 18, okay? Or supplementary angles equal 180, and so do straight lines. When you put supplementary angles together, they form a straight line. All right, so just a couple different ways to try to remember that. So it wants us to find the measure of two complementary angles, so they add together to 90. The measure of the larger angle is 5 more than 4 times the measure of a smaller angle. Well, it gives you your thought process here. It says if two angles are complementary, then the sum of those measures is 90 degrees. To find the measure of each angle, write an equation. First step. Let x be the measure of the smaller angle. All right, because it says the larger angle is 5 more than 4 times the measure of the smaller angle. Okay, it says the measure of the larger angle is this. It's 5 more than, okay, if you are more than, it goes behind because it's more than something. More than, you have to be more than something, and that something is 4 times the smaller angle, and solve for x. Well, we have two angles, all right? We have the smaller angle, which is x, and we have a larger angle, which is 4x plus 5. Step 1, solve for x. So you have your smaller angle plus the measure of your bigger angle, which it gave you, which this was your thought process from the description. And since it is complementary, it equals 90 degrees. All right, well, you have 1x plus 4x. I'm going to combine my terms. So that's 5x plus 5 equals 90. I have a two-step equation, so I subtract 5 from both sides. 5x equals 85. My last step, divide both sides by 5. X equals, what is that? 17. Okay, so the measure of my smaller angle is 17 degrees. All right, cool. It wants you to find the measure of the two complementary angles. So, okay, well, we found, here's our smaller one. Well, that's part of my answer. Now I need to find the measure of my larger angle because it wants the measure of both. All right, so the measure of the larger angle, it's 4 times the measure of my smaller angle, and it is 5 more than. All right, so we put that in the calculator. 4 times 17, 68, plus my 5. Measure my larger angle is 73 degrees. All right, so let's put that skill to the test. So basically what we did here, instead of creating a system where you would have two variables and two separate equations, we took one of our variables and we put it in terms of the other thing. So we put this larger angle in terms of the smaller one. So x was my smaller angle. Well, how did the larger angle relate to it? Well, it was 4 times as large, and it was 5 more than 4 times as large. So we're going to do that same process, okay? Same thought process. Now you can have this next one, you can do it a couple different ways. We're going to do it straight as the way it reads, but you can do it a couple different ways, okay? The thing with math is you can always solve these more than one way. You just have to show me the mathematical way you do it. You have to show your work. It has to be mathematically sound, and you do have to get the right answer. But there's more than one way to tackle. So I had you do this in class. I gave you 2 minutes to try it out. I gave you a minute, I think it was a minute or maybe 2 minutes to talk about it with your seat partners, and then we came back together with this one. So it says the difference between, all right, difference means subtraction. All right, so the difference between the measure of two supplementary angles, so I have two angles, they are supplementary, which means 180 degrees, okay, is 18. So the difference between them is 18. So we know is 18. Okay, cool. The measure of the smaller angle is the measure of the larger angle. All right, so the difference in them. So we got two angles. We've got angle X, okay, and then X minus 18. All right, so we are putting this in terms of my larger angle. All right, so the difference, we have two supplementary angles. Here's angle 1, X. Well, what do we know about angle 2, the second angle? If you take that second angle and subtract it from the first, the difference is 18. So we subtract 18 from it. Okay, so this is what we know. This is what we know. And we also know it's 180. Okay. So X plus X minus 18. So that's my second angle. One angle, two angles. Added together, they equal 180. 1x and 1x is 2x minus 18 equals 180. Add 18 to both sides. 2x equals 162. Divide both sides by 2. All right. And I had another thought process when I wrote these notes the first time. So, nope, 162 divided by 2, 81. 81. Okay. 81. So x minus 18. So I did this in reference to the larger one. I misspoke earlier. I'm sorry. X minus 18 equals 81 plus 18 plus 18. That's going to happen sometimes. Just saying. That equals what? 99. All right. When I was saying it out loud, it registered in my brain that I said something wrong. I apologize. So I did reference this in the larger. So we have our larger, and then the larger angle minus the 18. All right, so larger angle, this is my smaller angle. So our angles are 99 and 81. Smaller angle is 81. Larger angle is 99. There we go. So my summary, again, after you do the back of the notes, maybe give yourself a day, a couple hours, revisit your notes. What sticks out to you? What's the major thing you learned? All right. Perpendicular lines. Now I'm going to tell you, we learn a bunch of different things, a bunch of different pieces in Unit 2. And we're going to cover a lot of material, and we are going to use the individual pieces in future chapters. So chapters 3, 4, and 11, we're going to pull back and circle back to some of these concepts. Just letting you know, we're just laying the groundwork, and we'll circle back and expand on them later. So example 2, real example, tangrams. All right, tangram is a puzzle consisting of 8 flat shapes called tans, which are put together to form images. This looks like a swan, at least to me. All right, it says find the value of x and y. All right, you have two values such that line AD and EC are perpendicular. All right, that's important. When you have perpendicular lines, they cross perfectly at a 90-degree angle in all four corners. So what we know is where the angles come together, they equal 90 degrees. All right, that's important. And you have to be told that. So just because it looks like it's perpendicular, if you are not specifically told it's perpendicular, don't assume it is. All right, I've told you that. If AD and AC are perpendicular, then the measure of angle ABC is 90 and the measure of EBD is 90. All right. First, wants us to solve for y. All right, we're going to solve for y. Y is in this corner here. Well, we know it's perpendicular, so we know it equals 90. So 3y plus 15 equals 90. Two-step equation, subtract 15 from both sides. 3y equals 75. Last step, divide by 3. And we know y is 25. All right, so we found y. Now we got to find x. All right, so what we know, and we are looking for x, and we know E being D is 90 degrees. So we know these two angles added together equal 90 degrees. So we're going to have to set up a slightly larger equation, because we're going to take these two parts, add them together, and set them equal to 90. All right, so you've got your 7x plus 10 plus the other angle, which is 8x plus 5. Together, those make 90 degrees. All right, we have some like terms over here on the left, so let's combine. We got 7x, 8x, you got 10 and 5. So plus 10 plus 5 more is plus 15. 7x plus 8x is 15x. And we know this is still 90 degrees. We took this big thing, we brought it down to a two-step equation. We're going to subtract 15 from both sides. 15x equals 75. Divide both sides by 15. And now we know x equals 5. And that's what it wanted, the value of x and y. We found x and y. Now interpreting diagrams. All right. I told you we couldn't assume that those were perpendicular lines unless we were told. So this whole next section is basically solidifying the fact that you can't make assumptions unless you are specifically told something about the two things. So what can we assume? So rays CE and CF are opposite rays. Yes, because C is the common endpoints. So those are opposite rays. Angle BGC and angle KGC are a linear pair. Yes, they are a linear pair. Their non-common sides are opposite rays. Angle ABJ and angle CBG are vertical angles. Yes, these angles are non-adjacent and are formed by two intersecting lines. Okay, so angle BCG and angle DCF are congruent? No. We can't make that assumption. These angles are not vertical angles, and there isn't enough information given to determine this. Segment DE and line IF are perpendicular. No, there isn't enough information given to determine this. You'd be told that they were perpendicular. Angle EBC and GBC are complementary angles. Means they add up to 90. We cannot make that assumption. There isn't any information about perpendicularity or angle measures, so this cannot be determined. You have to be told something to make those assumptions. Angle ICH and angle HCD are adjacent angles, meaning they share a wall. Yes, these angles share a common side. And BC is an angle bisector of angle ECG. No, there isn't enough information. You need to be specifically told when a segment bisects an angle, as there isn't enough information about congruent angles, so this cannot be determined. So make sure you are not making assumptions based on a visual graphic, all right? Make sure you are reading the details that come and descriptors that come with these angles before you make your assumptions. There's an assignment out there, so good luck.